All right. Well, good morning. My name is Harry Ricker. This is the Cosmology discussion group for October 26th, 2025. So we got the right decade, century, I guess. Good morning. All right. I'm going to give a talk this morning. I'm going to talk about time. And I guess I would want to clarify, I'm not going to talk about time from a philosophical point of view. I'm going to talk about time from a physical point of view. I think we had a discussion about that yesterday. So from a physical point of view, that's the point. And the main point about the physical point of view is measuring time. So what physics is, I think, is about measuring time, not what time is, but I put that in as a title because that seems to be what people want to talk about. What is time? They don't really want to talk about what is time in physics. And I noticed there's a lot of videos on YouTube that want to talk about what time is, and physicists give their opinions, but I'm not really sure that physicists are qualified to give opinions on the philosophy of time. Let's see if this works. Uh-oh, something. Oh, there it is. Okay, what is time? So can everybody hear me? Is everything working?
Yeah.
All right. Um, so I gave a little introduction. It seems strange that I should be asking this question since I'm sure everybody knows what time is. Despite this, physicists seem to not know what time is, and I'm basing that on um, bunch of videos on YouTube about what is time. It seems that these physicists are viewed as experts and can pontificate about what time is. But when they talk, they seem to talk more about philosophy than physics. Um, they don't seem to know, and of course that confuses things because physicists are supposed to be experts about physical things, but they talk philosophy. Thus, expert scientists, they don't seem to know what they're talking about. They don't seem to know what time is and don't seem to be able to discuss it in a way that makes sense. And part of this problem arises from the issue of general relativity unified with quantum ideas. So that always kind of comes into the conversation. And then a lot of the discussion stems from cosmology, and of course there's a problem in cosmology is how does time originate in cosmology, because they have a big bang theory of cosmology. They don't have a steady state theory. I think in a steady state theory the origin of time is kind of mute point because time exists eternally, but in big bang they kind of have to explain how time originates because the Big Bang has an origin in time. So that I think is a problem for them. They're trying to explain that. Okay, I think when we talk about time, we have a lot of common language. I think people understand what they're talking about when they ask questions like, "What is time? When is lunchtime? How long will it take to do something?" That implies a knowledge of people seem to know what time is. What day is it? It's another concept of time. Some people say things, well, it'll take forever to do this task. That's a durational concept of time. And then you also hear people say things like this year really this year time really flies by. So time seems to be going at different rates. So people have an idea of what time is. And but Dingle, Herbert Dingle said, and I think this makes a lot of sense. He says there's three different kinds of time. So, or three senses of time that we use in language. He says, time is a date or now time. I gave some examples of that. What time is it? When you ask what time is it, I ask Alexa what time it is, and Alexa tells me 9:45 or something like that, particular time. So even Alexa knows what time is. So time is a date or now time. When is it now? And that's what a clock reads. When I look up the clock, it says it's now 9:07. Okay, then you have time as a duration, which is how long does something take? How long is it? How long did this task take? How long will it take before you get here from on your trip? How many days, how many hours it takes to get here on your trip? So that's time as duration. And then Dingle defines another sense of time, which is time as eternity, which is kind of what philosophers talk about. And the physicists that I mentioned before, they like to talk about this time as eternity, which is time has a past, present, and future, and the past and the future are separated by now. And physicists like to talk about block time, the block universe, which is this, we're going to talk about all of time as one eternal thing. So it's not time as now, it's time as eternal. All right. Anybody have any questions about that?
Well, I would just like to point out that time, you can overlay time on top of the Big Bang, and there's time before the Big Bang, and then there's time during the Big Bang, and there's time after the Big Bang. Time basically is a concept of humanity, and the progression of time is measured obviously by cesium atom.
Well, that
But
was the question, Rick. That's a point you can make during the discussion.
oh, okay, sorry. Carry on.
Okay. Now, my point is about what I'm trying to say about time is that I'm going to talk about it from the point of view of physical time measurement. And I'm trying to avoid the whole business of getting into philosophy. Okay. That's
Yep.
kind of what I'm trying to talk about here, because what happens is people mix up the philosophy and the physics, and I think
Yep.
this what's happening, and why I'm attributing this to Einstein. Einstein is primarily responsible for the confusion, because Einstein really is talking about philosophy. He's not really talking about time measurement, although he is disguised his philosophy of time as being a physical concept of time. Okay.
Right.
And so that's kind of my whole point in my talk here. Okay, so I claim, this is my claim, I'm claiming that that the real idea of measuring time really starts with Aristotle, because Aristotle says time is the number of motion and change. Okay, I'm simplifying. He says a little more than that. But to me, this idea of calling it a number implies that it's a mathematical concept. Okay, so now we have mathematics. And so now, once we bring in mathematics, I think now we're talking about physics. Okay, because now we're talking about quantity and number. So the quantity of time is measured by some kind of method. Now we have to have a method to measure what this number of motion and change is. So we have to have a method. So now we have to talk about how we're measuring time. So now we're talking about physics, because we're talking about a measurement and a measurement that produces a quantity, but it also produces a date, okay, because we arrange these days, the weeks, the months, the years, okay, in a mathematical order, okay, and we do counting. Now, a clock is a device used to measure the number quantity that we call time. Okay, when we say it's now, we look at a clock and we see what is the mathematical number that's on the clock. And that's really what time now is. And that now is also associated with a day, which is on a calendar. Okay, and the calendar gives you the name of the day, which would be Monday, Tuesday, Wednesday, Thursday. It gives you a time in the month, like the day in the month, like today's the 26th of October, and it gives you a year, 2025. Okay, and this is all based on counting of days, weeks, months, years from a reference point, of course. Okay, so the whole idea is that we're counting numbers, it's mathematics. And so what we have here is Aristotle is telling us that time is really associated with the number, and the number we obtain by counting. Okay, and most physicists use a similar definition of time as involving change by counting cycles. We count cycles. I talked about that. Days, months, years. Hence, time is the count of cycles that repeat uniformly. Now, the idea is that one day is the same as the next day. So days are the same. Then that also implies that weeks are the same. And then also implies that years are the same. So we're counting uniform quantities. And that's kind of an important point. Now, Newton defined time as mathematical and progressing equitably. So his definition implied counting numbers. So what really I think is important about bringing up Newton is Newton was working with mathematics. So he's doing numbers. So we could say that Newton really is doing physical time, okay? He's using mathematics, and we're counting days and weeks, seconds. So we're doing mathematics, and the mathematics that we use is counting numbers. Okay.
What's the difference between counting numbers and counting events, if any?
Well, if you want to, how do you count what an event is?
Well, and at
You
the
already
beginning,
mentioned days. That's an event.
Days aren't events. Days are durations. That's the whole point.
the
I don't
dur-
see the difference.
Well,
there,
that's why you're confused, Jim.
I'm confused about what exactly.
You're confused about what time is because you don't see the difference between an event and a duration, which is what Einstein confused the whole issue about. So what physicists think that time is an event, it's a now event, okay? But they don't think that there's any duration.
Well, an event that cycles, like say the cesium
Well,
130.
event doesn't cycle because, okay, so now you've just defined an event the same way that I define duration.
Well, they seem similar to me. I mean, they could see they could have the same definition if you wanted to. Oh yes.
Well, this is the whole issue. Thank you for bringing that up, Jim. The issue is you can't really define a duration in time unless you're counting something. Does that make sense to you?
Yeah.
What is it that you're
Well, to clarify, I would say an event lasts. Like there's a duration to an event. But yeah, I guess you're right here. They aren't the same thing.
That's not what physicists define as an event, I don't think.
Well, I disagree with much of what physicists say, so I don't know. Well,
Well,
how
what
we
do you- what do
define
you-
our
what do
terms
you-
is definitely crucial.
Well, I'm not defining events. I'm defining
Okay.
durations, which are units of time. Okay, that's
Yes.
what we're talking about.
Let's go with Harry. Your opinion we will listen to later.
What?
Harry, please proceed because don't confuse.
All right. Well,
Event, it's not duration. No doubts about it. Follow Harris definitions, not your opinions.
An event lasts time. There's a duration to an event. That's what I just said. I re-clarified myself, Vladimir. Thanks for your input, though.
well, what I'm
I had
trying
a
to,
question. Which Hamilton are you referring to? Is it the Scottish philosopher William Hamilton or the Irish mathematician William Rowan Hamilton?
I think this is William Roland Hamilton.
Okay.
Okay, and the reason I'm bringing this up is because he sort of is saying, in effect, basically, algebra, the science of pure time. He's sort of saying that we get our mathematical concepts from what time is. Does that make sense to you? So he says that he argues that mathematics is derived from the experience of time. And hence mathematics is derived primarily from the time that we experience. So our mathematical ideas derive from our ideas about time. And how do those ideas derive? Because it's through counting. Okay, it's through the elementary mathematics of counting. And then from that, we can get addition and multiplication and subtraction, because the count and is what I'm saying is counting and numbers the most basic mathematical ideas. And this derives from counting days, years, months, that sort of thing. So our mathematical notions derive from our notion of what time is. Does that make sense to you? All right. Well, now I'm going to talk about measuring time. Okay, and this is the interesting. My time isn't your time confusion. So this is a common thing. If I say the lecture starts at 9 a.m., I have to define what 9 a.m. is in terms of where I am or where you are. Okay, and so your time and my time is only the same if we're in the same time zone. That's really what that means. And so now that we have the internet and we can talk to people in different time zones, if you say, I'm going to call you on Zoom at a certain time, I have to tell you, what time zone I'm referring to. Okay. Well, this originates with Magellan. And I think this is an interesting story. Magellan, as we know, was the first guy to circumnavigate the world. And he didn't actually survive the voyage. He was killed in the Philippines. But when the surviving members of his crew got back, they were, according to their clock, it was Thursday. And the clocks, when they arrived back in Spain or Portugal, it was they thought it was Thursday, and when they got back, they found out it was Friday. And this was a real problem. How could this be? Because they were meticulously keeping track of the time on board the ship, but they were keeping solar time on the ship. So solar time isn't the same everywhere on the surface of the Earth. And when they went around the Earth, okay, on their voyage, keeping track of solar time for every day in the voyage, it took 3 years, they lost a day. Okay, so where did the day come? Where did the day disappear to? Okay, so to solve this problem that time isn't the same at every place on the Earth, we have time zones. Okay, we have Eastern Standard Time. Okay, well, anyway, the point about this whole issue is the same measurement procedure of time produces time measurement in different places. Okay, but does that mean?
Well, that's why we have an international date line, because
Correct.
if you go right around the Earth, obviously you're moving relative to the sun. Yeah, they had exactly the same problem with Jules Verne's Around the World in 80 Days, where he came back and it actually had he gone the other way and he'd found that he actually gained a day.
Right.
Here he lost a day, yeah.
Okay, so the point is, what we think time is. This is an example of time can be confusing based on how you make the measurement. That's the point. The point is what they were doing, the measure of time that was being used was solar time, and solar time is measured by noon because they can measure noon with instruments that would measure. When is local noon? Local noon isn't the same at every point on the earth. Okay, that's really the point. Now, the solution to this issue about time not being the same in every place was to establish time zones. Okay, that way, by time zones, every zone can have a time that's uniform within the zone. And then when you cross the border of the zone, then you shift by an hour. You either shift backwards or forwards. And that means that people can use local time, but it's not a precisely local time for their location. Okay, anyway, the military solves this problem by having universal 24-hour time. So that's one of the solutions to this confusion about time. The military resolved this. Everybody in the military uses the same time. So there's two times, really. If you're in the military, there's your local time, which you go to work and you come home, and then there's a military time that specifies how things are going to be done in terms of the universal time. And we use the same time in the ham radio community. I'm a radio amateur, and it's called Zulu time. But anyway, we're digressing a bit. Okay, this talks about the solar time method. I already described that, how the noon is measured locally. Okay, so why did I even bring this up? I brought this up because basically what it tells us is that how we measure time, okay, basically can mean that we arrive at different times. We can talk, maybe we think we have different times. We think that time is different, but it's really not. It's really an artifact of how we measure. If we measure time, if everybody used 24-hour time like the military does, there's no confusion about what time. My time is different from your time because everybody's using the same 24-hour time. Of course, we don't do that in civil life. We like to get up we like to have noon, local noon, be 12 o'clock. All right. Now, this method of measuring doesn't necessarily, the 24-hour measuring we have a uniform time, okay? So the whole idea of the Greenwich Mean Time, the military time, 24-hour time, the second is defined by this universal coordinated time, which is the 24-hour universal time. So the definition of the second isn't different. Okay, and presumably for mean solar time, there's a slightly different the second is defined slightly different from this universal time because of the difference that arises due to the rotation of the Earth. But I don't want to go into. Okay, so what the point of what I'm really trying to get at here is that this idea really is kind of an idea of absolute Newtonian absolute time. Okay, and Newton makes time mathematical and it's uniform. All the units of time, the duration of counts of units, they're all the same, they're identical. And this is really what physicists who measure time, this is how they think about time. They try to make time uniform. Every second is identical to every other second. Every day, well, days wouldn't be the same because you have these leap days and leap seconds in there. But anyway, the point is that the second, the unit of time measure being the second is uniform. And that's the principle that's being used. Now, Mach objected to absolute time, asserting it is that this is metaphysical. There's no reason to assume that time is uniform, apparently. Okay. And there seems to be some difference of opinion about what Mach said. I'm not going to go into Mach. I'm just going to point out that supposedly Einstein took up Mach's idea in his development of special relativity and his idea that time is not the same, that time is relative. Okay. Because Mach says you cannot empirically establish that time is not uniform. Okay. Now I'm going to talk a little bit more about that. Einstein's relative time asserts time is not uniform. Okay, well, isn't that, well, he says it's you might say it's relative, it's not uniform, but what he's really saying is that a clock in one state of motion doesn't read, the passage of time is not the same for a clock that's moving relatively to it. So the duration or the passage of time is not the same for different observers. I think that's what they mean when they say time is relative. But this gets into this problem of, he establishes this argument based on the claim that there is no simultaneity is relative. So there's no simultaneity, there's no simultaneous time. Okay, so now you're into the weeds of the confusion. So Einstein claims the duration of time is a dependent, not an independent mathematical variable. Okay, and that's the important thing. His claim is based on relativity of simultaneity, which asserts time measurement is not uniform for different states of motion. However, in this case, there is no time correction procedure to bring time into a uniform concept. Okay, so this is what I've been talking about. I've talked about this in previous things. Einstein doesn't acknowledge that I can change the calibration of the clock to make it uniform, to make the clocks all run uniformly. He doesn't acknowledge that that concept exists because it doesn't exist in his mathematical system. But I've shown that there is a mathematical system that we can make time absolute. Okay, now here's the problem with Einstein's time. It's not unique. Time is different for different observers in special relativity. We already know that, talked about that a lot. Time is different in different places in the universe. Okay, so that's one of their big points that they want to talk about, which I think kind of is confusing. Yeah, it could be different. What does it even mean to say that? Time is different for different gravitational fields. You know, that's a big conclusion of Einstein's theory. You know, the clocks running on the surface of the Earth is not the same as a clock running in a satellite. And so from Einstein's theory, his whole theory is based on the idea that time is what a clock measures. Okay, it's what a clock reads, but it doesn't take into account the idea that we just talked about earlier, which is your measurement procedure can give you an erroneous idea of what time is. Okay, so in other words, when Magellan went around the Earth, his clocks weren't measuring time the same as the time of clocks that were that stayed in one place. Okay, so does that mean when you go around the Earth, time is different from if you stay at one place on the Earth? No, we don't think so. We don't say that. Okay, all right. Okay, so now we have the GPS paradox. GPS atomic clocks change reference frequency due to orbital motion and gravitational potential. And so if you believe in Einstein, you'd say, well, time is different because GPS proves it because the clocks change their time due to orbital motion and gravitational potential. What they do is they change the calibration of the clocks to bring them into conformity with Earth-based UTC standard clocks by adjustment of the reference clock frequency. Okay, so the definition of time that is used in physics is UTC time. If you go and you look in the physics, how standards of physics, how standards of measurement are defined, it's defined in there. It doesn't, it defines what time is, it defines what a second is, which defines how time is measured. GPS uses that definition. So their clocks are adjusted so they measure time according to UTC time and according to the definition of what a second is. So GPS clocks so adjusted keep UTC standard time. So time is different for GPS clocks as asserted by science. Okay, so here's the question. Does that mean once we've adjusted the GPS clocks, does that mean that the time that GPS clocks measured is the correct time, or is it not the correct time? Okay. Scientists would say, well, because according to Einstein, time is relative, so time is not the same on the GPS satellite. Okay. So the point is, which GPS measured time is the correct time? The uncorrected time that GPS measures, or the corrected time that GPS measures? What's the correct time? Which time is the right time? Which time do we believe is the correct time? So did the GPS correction adjust or correct for the flow of time or the error caused by the difference in the clock's physics? Are we to believe that? Or I'm more of the opinion of Nick was saying yesterday, it's the clock that's wrong. Time didn't change, the clock changed. So all we're doing is we're correcting the error that exists in the clock. So if we say the clock error was corrected and now we're measuring the correct time, now we don't have any reason to claim or believe that time changed. So why do scientists believe time changes instead of the clock changing? So the answer is physicists don't have a theory of what time is. Okay, so they can say, well, they don't really know. They don't really know what time is. Okay, so we only know what we can measure. We only know what we can measure. And we think we're measuring time, and we basically design our clocks to measure what we think time is. Okay. Now, why did we change from the Newtonian idea about time, where time is universal and it's absolute? Why did the physicists change their opinion about what time is? So that's the real question. Why should we believe what physicists are saying about time, saying that time is relative because Einstein said so? Why are we believing that? Okay, we really should believe, in my opinion, that time is uniform and absolute because we can adjust the clocks to make time uniform and absolute, and we do that in GPS. Okay, so if we can make time uniform and absolute, why would we think that time is relative and can change when we have a measurement method that can measure time according to the standard way time has always been measured? Going back to Aristotle, then we have Newton, and it's all based on this idea that time is mathematical and it's counting and it's uniform. Why would we want to change that? I don't know. All right. So we don't want to, the problem here is that now if we accept time is relative, time then becomes a dependent variable in our mathematical equations. When that happens, the equations get really difficult to solve. Okay, so I think metaphysics says time is a dependent variable. Okay, so if time is a dependent variable, then we don't know what affects it. We're kind of assuming without proof since it's uncertain whether time changes or the clock's atomic physics changes. So here's the problem. We don't know whether time is changing or whether just the atomic physics is changing. So physicists can't tell us the answer to that. Why did they assume that time is changing and not the physics of the clock that's changing? So changes in either clock physics or time can be removed and made uniform without determining the cause of the change. Okay, so all we have to really do is put in the correction, okay? And I've shown in my theory how to put in the correction, okay? When you put in the correction, you get uniform time. Time is the same. It's the same in the satellite. It's the same on the Earth, okay? So hence the claim that time changes it's merely, my point is, the idea that time is changing is just merely a convention of the way physicists talk. Okay, there's no proof that time is changing. No proof of that at all. Okay, so so Mach said there's no empirical evidence that proves absolute time, but do we have any empirical evidence that proves that time is not absolute? Well, we don't have that either. So similarly, there's no empirical evidence that proves that Einstein's relatively changing time is valid, because we can make corrections to our clocks and time is going to be uniform and unchanging. So it's possible to establish uniform absolute time as it's done in GPS. So which of the metaphysical choices is more justified? Okay, so this is the point. The point is, why would we want to go around saying that time is this variable thing, it's relative, and we can't really pin down what it is, when we can just say, well, we measure time and we have a way of measuring time, and our method of measuring time is clearly defined, and we know what it is. So we can talk about what it is. It's clearly defined and we can measure it. Okay. We're going to run out of time here pretty soon. Can anybody look to tell me, I guess, oh, we got 2 minutes. Okay, here's the point I wanted to get at here. We have these strength now, because we have this modal definition about what time is in physics. Okay, we have people like Julian Barber, Carlo Rovelli, and they have these strange ideas about what time is, because now Einstein's opened up the door to this idea of relative time. Julian Barber says there's no time. Time has no duration between instants of time. Well, of course, that doesn't make any sense, because we know clocks can measure the duration between instants of time. So what he said doesn't make sense. How can he say something that doesn't make sense? It's contrary to what we know that we can measure time. He argues that the universe is timeless. What does that mean? Barber suggests that only individual complete moments exist. I don't know what a complete moment means. All right. Carlo Rovelli says there's no time. So now physicists are telling us that time doesn't exist. They can't really tell us what it is. It's this emerging from the time is a complex structure that emerges from a more fundamental timeless reality. I mean, that's metaphysical nonsense in my mind. Okay, right. So
it may not be fair to call them physicists. We might want to call them crackpots.
Well, they're doing philosophy. Okay.
I want some of what they're smoking.
They're doing philosophy. Okay, time is so my point is, time is an independent mathematical parameter.
Did you skip Lee Smolin? You had another slide there on his views.
Yeah, he's sort of trying to be he's trying to get into, he's sort of in the middle. You know what I'm saying? He's not really committing himself. Okay, so I apologize. Roger isn't here. He's not recording for us, so I have to do the recordings. It's kind of want to make sure I get this recorded. So I got the recording turned on.
Harry, would it be appropriate to make a very quick comment now?
If you want.
Well,
Something's not right here.
it's basically about terminology. You use the word physicists repeatedly in your quite good talk, I might say. But really, I think we should distinguish between the majority of physicists who are doing experimental physics work are really a quite level-headed, rational, well-grounded group of people. It's the crackpots among certain, a subset of theoretical physics people that I think you should be referring to. The experimental physicists are, I think, don't qualify for the sorts of critiques about them, about physicists in general, that your talk might imply or suggest.
Well,
That's
you're kind of that wasn't a short comment.
sorry.
I'm having a problem here getting the presentation back up.
It's up, but you're just not in slide mode.
Yeah, try slideshow again.
I can't get into slideshow. That's the whole point. It won't put that, it won't get that mode up. I'm gonna
You
try
might
it
have to
again.
change it and start again.
Okay, let me address Jim's point. If you open a textbook, they're going to tell you about Einstein. Okay, so I'm not really sure what you mean by hardworking physicist. What that terminology? I'm not sure what you meant by saying that.
Well, you just said it yourself. Those are the theoretical physicists. If they're starting talking about Einstein and relativity and so forth, I'm talking about experimental physicists who are a quite large group, in probably the majority of physicists. And
well, let me stop you. There's two different groups. There's like for instance, Essen, who is the did the atomic clock. He didn't believe in Einstein. Okay, so people who are building clocks and making clocks, they don't adopt Einstein's ideas when they.
Well, I see that you're agreeing with what I'm saying. So that, just to say it's physicists who are saying this, I think is perhaps a bit misleading. You might want to say,
no, I don't think it's misleading.
Theoretical
physicists. No, because no, it's not misleading. I told you the physicists who are talking this. Okay.
And they're theoretical physicists, probably not experimental physicists. That's the only point I'm making.
Well,
proceed.
Yeah.
It's okay. I've stated my point.
Well, my point was that when these people are introduced in YouTube sessions, and I'm just using that, this is kind of really my point that I'm making about this, is that these people are being introduced as physicists, not theoretical physicists, although they do almost all exclusively do theoretical physics. And
Okay.
they're introduced as physicists, and because they're physicists and highly acclaimed physicists to boot, therefore their opinions about time ought to carry some weight. Okay.
Well, you made my point. Thank you.
All right. I don't think there's really much point in going back to this. Let me see if I can get slideshow. It doesn't seem to be working properly. Something's wrong.
Well, part of it's up now.
What do you see?
It's legible.
Theoretical physicist versus Mach. While time and date is different for different places.
Let me get to I'm pretty much finished except for the summary. If you want to talk about what Julian Barbour has to say, which I thought, he's apparently written a number of books, and I think the idea that they're really trying to do is they have this problem, as we discussed in the beginning, that with the Big Bang cosmology, there's time has a beginning, an origin. And that's kind of a problem for them because they don't really have a theory of the origin of time. So they need a theory to create time as well as matter and the rest of the universe. So I think what they're trying to do is they're trying to figure out some way of explaining this cosmological origin in time by a theory of time that is compatible with their ideas of time and physics. And that is kind of causing them to get into these arguments that are more philosophically oriented. They seem more like metaphysics than physics. And
My
I was
question
just
is,
interested in what the so-called compromise that Smolin had arrived at. Was it something
I don't
similar?
really know that much about Smolin. I only put him in here because when I went on and looked at the AI included Smolin in my query about physicists and their time theories. He doesn't agree. He doesn't like the block universe idea. Okay, this is the idea of that. And when you use the space-time idea, they try to say that time, present, and future all exist simultaneously in what's called the block universe conception. Are you familiar with this?
Is that related to
He
this
seems to be saying only the
multiverse
present
idea?
exists.
Well, the block universe, it's kind of the way the people who do space-time think about time. So time went from being a succession of days, weeks, months, a flow. They claim time isn't really a flow, it's not a movement. And that the time is the all at once time, which is the block universe time. So time exists, the past exists, the present exists, and the future exists all at once in terms of the block universe.
yeah, no. The time is a concept, and I don't understand how they can say time began at the Big Bang. Time can be overlaid past the Big Bang during the singularity that was the Big Bang, apparently. These people think they know everything, but they don't understand, just common sense that time can be overlaid beyond the Big Bang. They say that there was nothing before the Big Bang. Well, there was a singularity sitting there ready to explode, and that had to exist for a certain amount of time. I mean, time is time. Time is now measured by cesium atoms, and the progression of time forward and backward can be realized. I don't. It's all of this talk about this type of time and that type of time and the time being able to change. It's not time that's changing. It's the clocks that are being at a different charge rate that are changing from the one clock that is sitting in stationary on Earth. That's the
Okay,
way I
well,
see time.
I think you summarized the difficulty. My argument boils down to we were doing okay when we had Newton, and we were doing okay with classical physics. And then Einstein came along, and then we kind of got knocked off the rails. And part of the, so now that we're knocked off the rails and we have this general relativity and this time is variable, space is variable. We have what time is kind of not really clear anymore. That's what I think has happened. And so physicists have these confused and muddled notions of time that they're trying to reconcile with their theories. I think that's what you were trying to say. And
well, yeah, it's not quite that detailed, but I mean, for myself, time is a progression. And we know that a cesium atom vibrates at a certain rate, and that's how time is measured. And it doesn't change. That cesium atom still vibrates at the same rate if it's not moving through a medium that's gaining charge to allow that cesium atom to vibrate at a different rate. That's what's happening, in my view.
Well, I go back a little further than Einstein, although he may have contributed very much to it. Classically, there was no confusion between time as an absolute concept or a mathematical concept and the means of measuring it. If Magellan or the other guy in around the world in 88 went around the world and there was one fewer or one more sunrise and sunset in that process. They didn't say time changed. They said, well, your apparent means of observation of the heavens changed. Or if you got an hourglass and brought it up to the moon and you found it measured a different rate of time. It was much slower in the lower gravity field. They didn't say time changed on the moon relative to the Earth. They said no, time's the same. So I actually date this to the transformations, I suppose what Lorentz did really with the Voigt transformations, and then of course Einstein developed on that. That was a confusion of time with the means of measuring it.
well, I think what
Now they're saying
happened
that,
was
yeah.
when Mach started to say, well, we have no empirical evidence that time is uniform or absolute as Newton asserts. That's when I think things kind of got muddled up. That's kind of what the point I was trying to make there is he was saying, what empirical evidence do we have that time is not uniform? So prove to me that time is uniform and absolute as Newton says. Okay.
Yeah, it's even
And
earlier than that, Harry. Leibniz said time is relative, and he's a contemporary of Newton. Yeah, the
yeah,
Newton Clark debate, for example,
yeah,
Leibniz Clark debate.
I'm familiar with that. I'm trying to basically stick to the to the physics. I'm not really a big expert. I do have the book on the Leibniz-Newton debate, and I've read that, but I didn't really want to get into that in this little talk. So I'm really sort of trying to connect it to Einstein, since Einstein is supposedly said to have been inspired by Mach, but Mach essentially, what's the word, repudiated Einstein's theory. He said he didn't believe it. And that kind of threw some confusion into the whole claim about Einstein was a follower of Mach.
But I think perhaps the Leibniz business was more to do with a, an argument with Newton about absolute space. Maybe time was a subset of that.
Yeah, it's both.
Yeah.
Yeah, I don't. The real issue, Newton sort of claimed that he took the authority of God to justify his idea of absolute space and time. And Leibniz, I don't think really particularly liked that idea. But I'm merely focusing here on the connection with Einstein, which which is usually associated with Mach.
Yeah.
And it's
Also,
interesting that you
Mark
say
was
that.
also a Mark was also a positivist, And Einstein was for a while, and then I think he played around with realism for a while, but you
Yeah,
don't really find consistency.
as you said, Mach influenced Einstein, but then you've also said, Harry, that he came to reject relativity, or the SRT anyway. I'm not quite familiar with that.
Yeah, that's kind of one of those ironic aspects of claiming, to have a mentor.
Mhm.
Rejects what he was meant to have influenced.
Yeah, I kind of get I've read a little bit about this. I can't really, say, when you get into these details about these historical aspects, it's a lot of complication, and I just kind of don't want to get into all the complications in my little talk here. My little talk is really based on the idea that uh, physics is sort of, everything was going great when they adopted Einstein's theory. Okay. And then quantum mechanics came along and everything was kind of really going great through the first half of the 20th century. And they made great progress. And then kind of things kind of got messed up because they couldn't mesh quantum mechanics and general relativity. And they're still struggling with that. And it seems to me that yeah, at some point they have to recognize that things are not really working, and perhaps a mistake was made along the way. And of course, I agree with Vladimir that um, you know they change away from classical physics, and the methodology of classical physics should be looked at as um, something that should go back to rather than. I think Einstein brought metaphysical ideas, and I think his whole claim about time is in space is more philosophical than physical. So and then the question that people don't really want to address, and I don't know that I addressed it that well, which is I don't see there's any proof that time is or space or changed by motion as he claims in special relativity. Where's your proof? Um, I don't think that it's a provable assertion. So I think because it's not a provable claim that it's more pseudoscience than science. So we have dead silence on that. But here's what so Carlo Rovelli, and this is just stuff that I got from AI, and he says that um, the familiar common sense notion of time as a uniform, universal, and flowing entity does not exist at the fundamental level of physical reality. I don't know how he can make such a claim. Time is a complex structure that emerges from a more fundamental, timeless reality. What the hell does that mean? There's no universal now, okay, based on Einstein's relativity. The rate at which time passes is relative, changing with both speed and gravity. A single objective moment or present across the universe is meaningless. I mean, Rovelli suggests the universe is better described as a network of events rather than enduring things. Time disappears at the fundamental level. This is just a snapshot of what AI told me about what Carlo Rovelli had to say. And I don't know that it makes any sense.
Insanity.
Yeah. Julian Barber is kind of interesting in that he says that Einstein's work is a muddle, which I thought was maybe looked like progress, but he sort of, although he acknowledges that what Einstein said didn't make any sense, he doesn't seem to repudiate it. He sort of takes the idea that yeah, it's like moving goalposts and the concepts aren't really clear. and it's kind of muddled, but he doesn't seem to repudiate it entirely. So this is what AI says. It says Julian Barber says time has no duration between instants of time. And of course, my view is, well, if that's the case, then how do clocks work? Does not, so time as a continuous flowing entity does not exist as a fundamental reality. I don't know what it means to say fundamental reality. I mean, my point that I was making earlier is that time is a human, empirical human observation, I think. So I think time is empirical at the observational level because we see days go by, one day becomes another day, and then we have months because the moon passes through the sky and we have different phases of the moon. And, as time went on, there's that word time again, they were able to establish the year and the length of the year through astronomical observation. So I think time is an empirically observed thing. And
you're talking about the experience of time there, Harry. And you can try to distinguish like between phenomenal time or the experience of time versus physical time. And I think I believe in both, but they may not coincide always. Like sometimes something seems to be going faster than it actually is and things like that as far as experiences go.
Well, what I'm saying is that time is something that's measured in physics.
That's physical. Physical time is measured, yeah.
Right. And so what I'm saying is that we should be talking about physical time when we talk about when a physicist gets up there, he should tell us when he's giving a lecture about time, he should make a distinction between physical time and philosophical time.
Or phenomenal time. You don't have to call it philosophical, but phenomenal time or experiential time. Yeah.
I don't know what those words mean, but
well, time is a human concept, right? So I mean, we make time what we think it is, and
yeah, but that's true. That's true for every concept in physics and science.
Exactly, and now we measure time by the atom, by the cesium atom. It's set now. As long as that clock runs, time is set. We can now extrapolate backwards and forwards into time, and we can give these points numbers. Time is a reality in our reality. In ancient times, before the counting of time, it wasn't. And it didn't matter. It was just you lived and that's it. Now we need time in our everyday life so that we can run experiments, so that we can go have lunch at the right time, dinner, go to bed. That's another reason why we invented time zones, is because we needed to, go to bed at a certain time of our biological clocks.
Well, that's an interesting point.
They help set our biological clocks better, or synchronize our biological clocks better. Because if the same time was on the East Coast as it was on the West Coast, people's biological clocks on the West Coast would be all skewed. And that's the reason why we have these time zones, is purely because it helps synchronize our bodies to our experience of daylight and night. That's it.
Okay.
This is sort of just maybe a silly point, but people on the other side of the world or just wherever could go to sleep at our time. Like say we go to sleep at say 10:30, they might go to sleep at, 4:30 in the morning, or just whenever. But I see your point, Rick. I mean, just like it makes it more convenient to have time zones, I think.
Well,
Right.
we
That's
approximate noon to be when the sun is highest at each place, but we don't make it exactly so because there are political and geographic reasons, um, to standardize maybe on a place of trade or the capital of a state or whatever. And also, of course, the daytime changes. You have an equation of time which varies through the months. So, the sun could be highest half an hour earlier or half an hour later, and then you also have daylight savings time. So we're approximating the middle of the day and the middle of the night to be the time that we'd be sleeping, but we're making compromises for political and administrative reasons.
Well, what I'm saying is if everybody went to bed at the same time all around the world, people would be sleeping during the day, afternoon, morning. I mean, it doesn't work that way. It all works on our body clocks. Our bodies are tuned to what, 24.5 hours or something like that. Our internal clocks. So the need for us to have individual time zones is a perfect fix for that. Need for a biological, or to mesh up with our biological clocks.
which does kind of create this problem because as a ham radio operator, all events are defined in terms of UTC time, or Zulu time, as the military calls it. And it's kind of, there is kind of a confusion because I can never really remember what UTC time corresponds to, the time of day. And that's also confused by the daylight saving time shift back and forth. So there's
Well,
Yeah.
UTC is GMT. It's
Yeah,
just a
Greenwich Mean
standardized
Time. I was just going to say it's
universal.
Greenwich Mean Time, no?
Yeah, and it's taken the Greenwich meridian as being zero, and then going east or west, plus or minus so many hours. But I mean, in ancient times, when time was determined by the sundial, basically the shadow of the sun at a particular time,
right.
then every particular place on Earth would have midday, and then midnight was, when people were sleeping and so on. And if you traveled 50 miles down the road, well, you had a different time because so they standardized. They said, well, let's have zones which could be hundreds and hundreds of miles wide, which would have the same time. And therefore, midday would not be exactly correct at the periphery of those zones. So, in other words,
Yeah.
what Rick was saying about the uh, biological clock was more faithfully adhered to in ancient times when we didn't have modern political and administrative considerations, and also, of course, communications. So we couldn't communicate with parts and
Yeah,
distant
when the
parts of the world.
sundial said it was noon, it was time to eat your lunch.
Yeah.
Assuming you ate
Well,
lunch.
and before the sundial, what was there? The invention of time. I'm going to get into the electric universe and Saturn theory. Saturn was our ancient sun. It was sitting in our northern pole. We could see it plain as day. And between Saturn and us was Mars and Venus. And when we came into this solar system, we could see a crescent of light being shown on the body of Saturn. And as it moved around the body of Saturn one time, that was a day. That was the reason why Kronos is given the moniker, the creator of time. Saturn Kronos. We watched this crescent of light move around the body of Saturn, and this is the reason why the Egyptian day and night solar boat is upside down during the day because it was at the top of Saturn. The crescent was at the top of Saturn during the day, and it was upside down, and then the boat at night was right side up. There's a, it's just humanity. Time is a progression of events at the beginning.
Well, that's different from what these physicists are saying, Carlo Rovelli and Julian Barber. They're saying there's only thing that exists is now, and there's no, they don't really seem to acknowledge anything like a progression or a duration, which I
Well,
find.
in the beginning, I think it was a progression of events. It was watching this crescent revolve around the body of Saturn. And when it got to its starting point at the bottom of Saturn, another day would start.
Question: how do those people that you just mentioned, sir, that time is, I'm not even sure what you said there, but how do, there's only one moment, I think you said, or the here and now. How do they explain then things like a cesium half-life phenomenon, a fairly steady decay rate? How do they explain that?
Okay, we're kind of confusing what the Julian Barber and Carlo Rovelli are talking about. They say there's no flow of time, there's no progression of events. They say there's only now, and there's no duration, which I find very confusing how they could reach that conclusion.
Well, I would say I agree with that at some level. I think the concept of time is often, well, I mean, you know how you look in the dictionary, there are like countless definitions for some words, and time is similar. I mean, time. Oh, well, let me read some that I have here that I wrote to the side. I'd say that the present is what is real. It's where it all happens. However, all of the past was once the present, and all future events shall inevitably occur in the present. I'd say time is the temporal order of reality. The existence of time is unavoidable and inevitable. It's an inherent condition of reality. The concept of time isn't dependent upon the existence of clocks or even all of the physical phenomenon that exists throughout the universe. If nothing somehow existed, time would go on. That's what I had there.
So that's your view.
And I would agree.
Oh, cool. Thank you.
But I think another person in our own group who's come to some similar conclusions about dismissing time, if I'm not misattributing to what he's saying, is Nick Percival. He said, I think, at a couple of his presentations at the end, here's my surprising conclusion from all my analysis of time and cesium atoms and all this. Time is illusory. I thought that's the conclusion Nick came to.
Yeah, it has to do with the dilemma that I was trying to explain. The dilemma is you can't really pin down what it is. Okay, we know that you can't really explain it. You can't really pin down whether it's uniform or not uniform, right? We can't really, it's like Mach was saying, well, give me some empirical evidence about whether time is, as Newton said it was, absolute and uniform. He didn't accept that as being true. And so he wanted some proof that it was true, but I don't think that you can prove that, right?
Again, I go back to the point, time is what we make of it.
Right. And I think that's really kind of what the issue is. The issue is that different people can sort of try to argue that it's something different than what you think it is. I think that's what Carlo Rovelli and Julian Barber and those guys are doing. They're trying to make it fit into their notions of what the universe is or has to be.
Well,
And
with
Evidently,
with the invention of the cesium atom clock, I would say time is immutable now. It is
well,
a progression
we
of
cannot measure time
vibrations.
with precise accuracy. Even with the cesium clock, there are errors all over the place. Have a look at the around
Oh,
the
I
world.
agree, and I agree.
You know, so um, yeah, I've just lost my train of thought, but I was going to, yeah, yes, it's an idealization. That's what I was going to say. So just as in measuring space, we started by measuring the Earth, geometry. We're making measurement of the Earth. We're setting out right angles to build pyramids and that sort of thing. But there are errors of measurement, and we idealize, we form geometry into an idealized science with a perfectly straight line, perfectly parallel lines, and points which have no magnitude and so on. So the same with time. Any means of measuring time, whether it's by the sun or by hourglasses or by pendulum clocks or by cesium atoms, subject to actually quite great errors. So we idealize it. We say, well, the distance between two events, it idealized in this concept, in this mathematical concept. Well, the question is that immutable or not? That idealized quantity. And I would say, contrary to Mark, that it is the onus, it is is the onus of people who say that it does change to give me experimental reasons why it does change. Well, they could say, well, look, we know that a cesium clock changes depending upon the gravitational potential or depending on its speed. But then we're back to square one, which is, well, is that not a physical effect rather than time changing itself?
Well, I'm not sure that it's gravity that's changing the speed of the cesium atom. I think it's the charge that clock is experiencing, that clock is gaining as it's moving through the atmosphere and then moving out of the atmosphere into another area that has a different charge. So I think it's charge that drives
Well,
everything.
whatever the fundamental charge is, it's changing because of the gravitational potential. If you keep the gravitational potential and you start moving in it in an atmosphere or through different charges, you don't get this change. So the
Yeah.
fundamental point is that it's a physical change rather than time itself.
Hmm.
yeah, that's what Nick was trying to talk about yesterday, if you recall.
And that's why I refer to the cesium atom clock that is sitting there at one point on the ground that doesn't move. We take our time from that clock.
Well,
And
actually, it's moving because it's rotating with the Earth.
well, I'm saying that it's not moving relative to the Earth.
Right to the surface, yes. So,
Yeah,
but its motion on the surface of the Earth is constant
well, the
enough
Earth is
so that
spinning and that spin is motion, and then the Earth is spinning around the sun. That's another motion, and then we got the sun moving through the galaxy. That's another motion, and you add all of that up, that means nothing to that clock that's sitting there stationary on the Earth. That's my point.
okay. So I didn't warn you about the clock cut timing out.
Time. We use time all the time,
Yeah.
Yeah, I
and we
know.
typically don't think about it.
Well, I think we know what time is as far as our own perceptions are concerned. But um, when physicists start talking about it, it could get muddled up. And they're supposed to be experts on what time is.
Well, if I hadn't taken account of time this afternoon, I would have been just joining the conference now because we got rid of daylight saving time this morning. So I had
Oh,
to take that into
yes.
account and start an hour earlier.
Yes, I know.
That's a bit of a proof that it's
You know,
real.
there's a movement to get rid of that. Um, Apparently in Spain, they want to get rid of daylight saving time in Spain. And there are a lot of people who hate daylight saving time. And because of the business, they don't like the hassle of changing, when you wake up and when you go to sleep and that sort of thing. But I have to admit, I like it a lot in the summertime I mean, I love it in the summertime. I just can sit there and have daylight till 8 o'clock.
Yes, I rather like it as well. It means it gives you an idea of the changing seasons. Um, but the EU as a whole is trying to persuade member states to get rid of it, and I think the same thing is happening in North America, in the USA and Canada. But
Right.
I don't know if they will. Maybe ultimately. Hmm.
All right.
Okay.
Do you have anything to say
Can I
about
ask the question? Can I ask the question to Jim? Jim, in your theory, what is time? It
Well,
was a great presentation yesterday you gave us. You blamed everybody, any model, but I want to know at least one point of your theory. Time. What is time in your theory?
well, time is a primary constant in the Keene scale. My theory is very realistic or realism oriented. A lot of the
well,
philosophical.
I think in your theory that there's some universal computer that's got a clock in it, right?
Well,
Clock, yeah, immediately time.
I'm
Yes.
not sure how to answer that, but in fact, the ether concept in binary mechanics is presented in terms of the spot cube lattice, a lattice of spot cubes, and these are actually when you think about it, a sort of machine. And so, yes, this machine seems to operate at a certain rate. And so there you go. That's what the definition is. It doesn't, binary mechanics probably doesn't make more specific claims beyond that.
But
That
of course, there's a very
really ether
fundamental thing
is
which you've
structured
stressed yourself.
space. Excuse me?
There's a very fundamental point, Jim, that you've stressed yourself many times. It's fundamental to your whole theory, of course, of the discrete nature of time. Now, of course, many of us would counter that. We would not have that as a working hypothesis. And certainly the conventional classical view of time, the absolute, it's Newtonian view, would not have that concept in. I mean, you might analyze it by using discrete elements in, say, the infinitesimal calculus, but in the limit, it's a continuous variable. Now, that would seem to be contrary to your ideas.
I agree. That is contrary. Yes.
So does
I
time?
don't understand your time, Jim. I don't understand, clock. What is the measurement tool? How you measure your time? Because
Well,
physics is measurement. I agree with Harry, absolutely.
Ian mentioned the pendulum type clock that swings back and forth and helps us measure time. In other words, it's a sort of a machine. The binary mechanics concept may be a little more abstract, but it's basically the same idea that this structured space as a lattice of spot cubes is really a sort of machine, and it operates at a certain rate.
By machine,
And that's as far as binary mechanics can say.
by machine you mean a computer like?
No.
Machine in time,
I mean that the spot unit is probably needs to be logically composed of a number of components. Certain sides of, if you imagine the spot unit as being two size L, where L is the length constant, two size L cubes adjacent to each other, you have this, what I call spot unit structure. It's not merely a assertion that space is filled with these structures, but that these structures are sorts of machines. In other words, a one state or quanta in this structure can't move in any arbitrary direction. It can only move in a certain direction. So that, in other words, some of the walls of the spot cube, of the spot unit must be considered to be sort of barriers. There also must be sensors in some of the walls of the spot units to sense the adjacent state in other spot units that are adjacent, because the equations of binary mechanics require that the information about the state of those adjacent locations is required. So that those are called the potentials in binary mechanics equations that I presented here previously, incidentally. So yeah, so you may view that the spot unit is actually a sort of machine. Some of the walls or sides, two-dimensional sides, if you will, of the spot unit that you may recall in various illustrations that I have presented, are maybe considered to be sort of valves, a valve in which a one state can move through it in one direction, but cannot move backwards, like the valve in the chambers of the heart. Fluid can only move in one direction, generally speaking, in that example of bulk flow. So in the case of when we're looking at the spot unit, you're looking at a sort of machine. And binary mechanics, by reverse engineering the so-called fundamental constants, which it now calls secondary constants, derive the primary constants for energy, length, and time. But really, I haven't gone further than that. In other words, there's room for other bright minds to come in here and assert themselves, because apparently the quantized unit of time in what I call the Keen scale, which is the primary constants of binary mechanics, apparently results from the operation of these units, which are actually little machines. And so,
you described a lot, but what is your idea of time? How does time work? What is time? What's the definition of time?
Time, Jimmy.
Well,
exactly
that's
the
what
answer.
we need to understand. I presented with the spot unit and the spot cube, which is composed of spot units, as a machine. And in other words, quantum move through these items according to the equations of binary mechanics. If that is true, one can then assume or postulate or hypothesize.
Well, let me ask you this question. As I understand it, your equations are like a shift register, and every clock time unit causes the equations to output a result, right?
Well, that is the one of the bit operations of binary mechanics. Yes, that's what's called the unconditional operation.
Time is what causes the equations to change or produce changes. And so,
well, what causes that is I would say remains unknown.
That's time.
It's good.
I mean, just saying that's time, I don't think is, to me, any adequate explanation of how this particular machine.
Well, the machine is either operating in time or not. If it's not operating in time, it's static and nothing changes.
Yes.
Well, that doesn't happen, because right now I see movement on my computer screen, so things are happening.
All right.
So you're just posing a scenario that doesn't happen. That manifestly and obviously does not happen. I'm not even sure why the question is even raised.
Well, in a computer, nothing happens in the computer unless the clock issues a command to the shift registers and the operational devices. So when the clock arrives at the operational devices, they change their state.
Yeah, so that's a good way to enter into the fray. You say, does this machine operate like a a computer operates with a centralized clock. I tend to think not. When I look out the window at the universe, stars at night, this is a vast, big thing. Okay, and the whole idea of there being some central clock somewhere guiding the whole thing, it just doesn't make sense to me. But that's just me. I mean, it makes sense to other people.
That seems to be what these egghead physicists are struggling with.
Right. Well,
Let me continue because
okay. Yeah.
Jim, I'm sorry, I didn't understand your explanation of time. I'm very sorry. There is, first of all, tool to measure or vice versa. Your
Well, I
equations you
didn't
measure.
present
I
any
don't know what you're
explanation of
talking
time,
about.
so that you don't have to worry about not understanding something which I have never presented.
Present
Either in
maybe
any of my
next time because I
publications or
misunderstood
elsewhere.
right now your explanation. Guys, let me continue. I'm very sorry because I had my patience for 2 sessions. Let's take a look at my point about the time. First of all, let me tell you, even spinning of our Earth, it's not homogeneous. Do you know that every day, 24 hours? No, it's different time every day in millisecond regime, but it's different. And I'm watching this difference for 3 years. I published this result. I showed cesium atoms, of course, their performance depends on a gravitational field, as Ian told you. That's why whatever we have on our Earth atoms, it's something helps us to understand solar time. Solar time. You're talking about day, time, year. It's solar time. Let me ask you the question. Solar system exists 4.6 billion years. What was before? Did we have time before solar system? Before solar system at all? The point is, time belongs to universe, to the world in my model, or it belongs to solar system only. You're talking about solar system. Okay, we live in solar system. It's convenient for us to see 8 in the morning, 8 in the evening, but it's a solar time and it belongs to us, to solar system. That's it. What was before? Let me ask you the question. What was before? How to specify, how to define even time before solar system? Jim, what you tell? How to specify time before you existed, solar system existed? What is time?
Well, I'm all ears. Tell me.
He's asking you, Jim.
Guys, let me tell you. Of
Well,
course,
I've defined time in terms of a primary constant, which is used in physics research and also in practical applications in science, in industry, and commerce. That's the definition
primary
of time
constant,
that
it's
I have
constant.
given.
Time
And
is not constant. What you talking about?
well,
I agree with you,
I think
Vladimir,
what
that
you're
our
talking about is two different things. In binary mechanics, the primary time constant is a fundamental primary constant of physics. Various processes, such as the Cesium clock, the amount of milliseconds that occur in a single day that Vladimir was just talking about, those things can vary. So it's like apples and oranges. If you want to talk about one, yes, time is a primary constant in binary mechanics. If you want to talk about the other, how things vary, various measurements vary.
What does it mean constant? Time
I have
is
no
changing.
objection.
And you're talking about primary constant. How come? I don't understand. Variable number or it's a constant?
Well, you yourself in your presentations, my dear friend, have used the so-called fundamental constants, the speed of light, Planck's constant, and so forth, as in rather long presentations of various equations that you presented and so forth.
Never I told about the time as a constant.
So now you're telling me that you don't believe they're constants.
Yeah, I believe in constant, but not in a constant time. Time is variable. That's it. Simple like this. Let me continue. I'm very sorry. I wanted to know your opinion. I misunderstood it. Sorry. Constant, for me, constant is constant, but time is variable. Guys, let me tell you another word. What was the time before existence of our solar system, before existence of us, and all these questions we asked today? What is it? In my model, the main player is cosmic medium. It existed long before we started our solar system and our life. Cosmic medium, this is the main point of my model. Cosmic medium is at the same time instrument, measurement tool for time. Time is absolute because cosmic medium, it's filled out the world, it's homogeneous, isotropic, and what is important, it's absolute. It means in any place of our world, time is the same, absolute. Why it is the same? Because cosmic medium is a tool, is an instrument to measure the time in the world. What is the parameter, variable parameter measured by cosmic medium? So-named impedance. It's so-named, sorry, can you hear me?
Yes.
Yeah.
Oh, okay.
Yeah, I
Let
can
me
hear
tell
you.
Okay, good. There is so-named impedance of the medium, any medium, water, air around us, there is impedance, or in the other words, wave resistance. And if you will measure the wave resistance of the cosmic medium, you will see there are some changes. And these changes inversely proportional to cosmological time. In my model, this impedance parameter, it's a Hubble parameter that equals tau in power minus one.
Question.
Inverse. That's it. That's it. You have your cosmic medium as an instrument. It's filled the whole medium, and it's absolute. Cosmic medium, it's absolute tool, absolute time, and time is the parameter of this cosmic medium. You're measuring this parameter, you can see your cosmological time. Simple
Hello?
like this.
Have you found the ether, Vlad? Have you measured the
There
ether?
is no ether. Forget this word. There is a cosmic
That's the
medium
cosmic
consists
medium.
of particles.
That's the
Ether, I
cosmic
don't know what
medium.
does it mean.
That's
Well,
the
he
cosmic
has,
medium. The ether is the cosmic medium. The
No,
photonic,
don't name
photons,
this word.
electrons,
Ether.
atoms, and every particle that's out there is what EM flows on.
I'm very sorry. Ether, give me the definition of ether. What does it mean, ether, in your words? What does it mean, ether?
The cosmic medium.
Sorry. Cosmic medium, it belongs to my model. Don't
Well,
name
Mainly
it.
you're talking about terminology.
All right. Well, then
It's not terminology.
I would say the
Cosmic
cosmic
medium
medium is very
depends
similar
on.
to the ether, though. The cosmic
Yeah.
medium. There are many different ether theories. I mean, is it Lesage or Lesage, Laplace, or someone who had the theory that minuscule particles travel in all directions, and that's how things propagate through. Other theories are there's positron electron pairs, and that light and gravity propagate through that. There's so many different theories. I mean, sometimes it's fixed and stationary, sometimes it flows around. But I mean, it's the Michelson really thought it was simply to propagate light, but nowadays it propagates gravity and everything, even creates reality.
You mean ether is ether? There is such an ether in history of classical physics, but there
okay.
is no definition. It's only transmitter for light, and that's it. And what is the content of this ether? What is the content? It depends on what? What is the
Well, it's
content of
related
it?
to the impedance that you talked about a second ago, Vladimir, and also the speed of light, if you don't mind using the term.
Speed of light, I don't like it at all because I don't know what does it mean light. Because radio waves, it's not light. And I'm not talking about,
Well, the speed of
speed of light,
electromagnetic
I don't know
radiation,
what
I
does it
use the
mean.
term. So we have a difference there. There's no point in arguing about that until we're
Radio
No.
waves,
But you know what I
radio
mean?
waves.
Yes, the
Guys,
constancy
let's
and
come back to the
Did
to
you
value
the
say,
definition
zero.
of time.
did you
Definition of
say,
time.
did
I'm
you
sorry.
say that the cosmic medium existed before the beginning of time?
There is no name of beginning of time. You know,
Oh,
you're
okay.
telling
Okay.
some
I'm just asking.
definitions, and I don't know what does it mean, beginning of time. What do you mean? Guys, don't
Vladimir,
I
put
was
Vladimir,
just
some
looking
words
for
without
clarification.
definitions.
I was just looking
Vladimir,
for clarification.
I thought that the 4D nucleus began time. Maybe I was mistaken.
Well, Vladimir has repeatedly said that the thing started at a certain time, some 14 billion years ago. Maybe he's given up
When
on
we
that
can
because every
introduce
time we
the
hear about this theory, things have changed.
You make a
Let me
distinction
tell
between
you
the age
guys,
of the world and the age of the universe, I think. Is that not correct?
let me tell you my definition of the beginning of time. You cannot start talking about time before you will create the very first ensemble of particles. This is the main point of my model. You have your particles, and the very first ensemble of particles, when you can introduce the notion medium. Without each particle, it's not a medium. Only when you have your combination of them, ensemble of them, and you can, or at this time, we can talk about the medium. You started medium, you started your time. There is no beginning of time because first of all, you must create the first ensemble of particles to introduce this notion medium. And only then you can introduce space, time, and gravitation. All these three notions only when you will start with the very first ensemble of particles. This is the beginning of classical time because classical physics, it's ensemble of particles. Ensemble, always. Even these notions, pressure, volume, and all the other classical notions, all depends on ensemble of particles, on statistical thermodynamics. It's shown more than 100 years ago. You know, that's why after Maxwell equation, Maxwell, distribution and all this stuff, temperature is Maxwell distribution. It's an average kinetic energy of the medium, and so on and so on. Pressure, volume, all these notions we use in our real life depends on what? On the medium, on the ensemble of particles. You don't have this ensemble, you don't have medium. You cannot talk even about space, time, and gravitation at all.
Well,
And of course,
is it possible that time could have existed before the ensemble of particles entered existence, though?
I'm sorry, one more time, I misunderstood you.
Is it possible that time existed before the ensemble of particles entered existence?
No,
I mean,
because as I told you, you can introduce notion of time when you have your medium. There is no medium, there is no time. There is nothing. There is no space, there is no time, there is no gravitation, nothing. Only when you created this cosmic medium, the very first, at least, ensemble of particles, only then you can introduce all these classical notions.
so
Think about it,
so the
Mary.
particles create time, though.
I'm sorry?
They create so particles and physical phenomena create time. Is that what you're saying?
Not particles, ensemble of particles. Guys, we have a different classical laws against quantum physics, quantum mechanics, and even Jim, mechanics, binary mechanics. It's many times, Jim, I told you, as for the quantum physics, you can go with your model. I have no guess anything about it, but don't go to classical physics because it's a totally different stories. You must take ensemble of your blocks and to introduce new definitions, new physical laws, everything new when you have your ensemble.
Well,
Many times I told you about
if you
doubles.
read about binary mechanics, you'll find that a lot of the work uses classical physics concepts. For example, the formula for angular momentum as an
It's
example.
absolutely wrong. In quantum physics, you are trying to put classical notions. It's wrong.
Are you
On the
saying that
contrary,
I
you
don't
must
know
take
what is in
your
my own
particles or
publications?
blocks, whatever, to collect them and ensemble, and only then you can tell something about the classical physics.
So
You see it?
you're asserting I don't know what is in my own publications. If you read those, if anyone reads them, you will be shown to be absolutely false in your
Well,
statements.
my personal view is that that time isn't dependent upon the existence of physical phenomenon, that it's infinite, that time has always existed. I mean, it has to. You can't even picture time. I mean, you can't picture time not existing. If everything froze, I mean, well, how much time did it freeze? You know, I mean, like, time is inevitable. That's my view.
Tell you one more time. There is no medium, there is no impedance parameter of this medium, there is no wave resistance of this medium, there is nothing to talk about. This is my main point. And you have your absolute time because it belongs to the whole cosmic medium, to the whole world. Instrument, what is the instrument in your view, in your point? In my point is wave resistance of the cosmic medium around us. That's it, simple like this. That's why absolute time, because medium is absolute. It's all the same in the whole world. There is solar system, there is no solar system. You have the same cosmic medium and changes of the parameters of this cosmic medium. Energy density of this cosmic medium is our gravitation. Simple like this. And it doesn't matter. Magnetic parameter of this medium is our space. That's why you don't have medium. You cannot start talking about all these definitions. If you have these notions, you cannot talk about time. Time before Big Bang, I don't know what do you mean. What are you asking about it? Or what does it mean it was forever? I don't understand forever.
Well,
You
this
know,
is the
forever.
argument that various rabbis might give for believing in the chapter on Genesis of the Bible. You just have to believe it.
I'm not believer. Unfortunately, I'm not religion guy. I am physicist. And I absolutely agree with Harry. He is absolutely right. We have absolute time in all the world. And we have variable clocks. Variable clocks. There is cesium atom. They have a different rate in different gravitational field. It's well known. Guys, this our even atoms clock, it works only on the surface of our Earth. That's it. But if you will go outside, it will be a totally different story. Even this gravitational shift of time, it's a bullshit. It's a change of the clock, not of the time. Harry, thank you so much for very good explanation, the difference between time and clock. I'm absolutely agree with this point. Time is absolute, clock is variable, depends spinning of surface, gravitational field, whatever. It's our convenience to count something, to say, oh, it is the morning time, or it is the evening time, but it works only for our convenience. Solar time, it's our convenience. And don't spread this, solar time before solar system, guys.
Time
It
is a human
existed
concept,
before.
and it's what we make of it, period.
That's why,
Well,
in my report, in my papers, I told many times, cosmological time, cosmological, it's not solar time. It's not even time, relative time in Einstein theory. Forget about it. Time is absolute.
well, I
But
think
Okay,
I
what
think
Vladimir,
we're
what
getting
Vladimir,
towards the end here, and okay, so finish your thought. Remember, we only got a couple of minutes. I want to.
what Vladimir and Harry have said today, they both agree with respect to the idea of an absolute time with the fundamentals of binary mechanics. I just like to put that on the record. Thanks for the agreement.
Okay.
What is the most important? Let me tell you, Jim. It's not, belief. It's absolute, not absolute. On the contrary, in my model, I showed as a physicist why it is absolute. Why? What is a model explaining why it's absolute? Because it depends on a cosmic medium that fills out the whole world. Simple like this.
Yeah,
And
I'm not
nobody
sure
before
if,
me
if they
talked
don't
about
say
it.
that. I mean, binary mechanics, you say, Jim, results in accepting an absolute time. That's fine. But that doesn't imply that anybody who accepts an absolute time, such as Vladimir has just stated, agrees with the binary mechanics concept thereof. He might accept absolute time for very other reasons. So I'm not sure we're all quite agreed, but I think most of us here probably tend towards acceptance of a classical idea of absolute time. I certainly do.
I think Ian's point is well taken. Inquiring minds will always have a lot to discuss and debate, and I don't think debate about a lot of these questions is ever going to end, nor do I think it should end. I think discussion, whether heated or just calm and steady, is something which can be very productive. And I really welcome that not only in today's presentation, but in several previous presentations, Harry seems to have come to the conclusion, at least as far as I see it in my perception, of some things that are quite in agreement with what binary mechanics and my work therein are saying. Thank you, Harry. And that doesn't imply that Harry agrees with everything in binary mechanics, as Ian just pointed out. But I think it's noteworthy to put that on the record. Thank you.
I agree with James. I think that once discussions start becoming, a personal attacks, a line has been crossed, and this group is amazing. I love the fact that you don't go into a personal attacks. It's kudos to this group.
I agree, Rick.
All right, thank
I
you.
don't understand your word attacks. Asking the question, it's not attacks. It's trying to clarify some notions.
No, I'm not talking about.
Man, you
I'm
are
not
talking about
I'm
different
not.
words.
I'm
Sorry.
not. I'm not.
Please don't use these words.
I'm not.
Attacks or some aggression, maybe, and something
You
else. We are
misunderstand.
physicists, and we're asking each one question. That's it.
You misunderstand the point of my point. My point is that this group does not go into personal attacks.
Okay, thank you so much. I misunderstood it. I am so sorry. I don't like this word. I don't
like it either. That's why I like being here.
Okay, guys. It's good.
Okay, well, I
Harry,
appreciate that.
thank you so much. You are raising all the time the very good questions for all of us. Some notions, well-known time, very known, but nobody knows what does it mean. And some great physicists, they canceled it. There is no time, and that's it. Simple like this. It's a bullshit, man. Time, of course, exists. It's absolute. It's the same in all the world. And I put the parameter which explain why it's absolute time. Why? And I gave you the even tool, instrument, cosmic medium. Measure this wave resistance, impedance parameter of it, and you will find cosmological time immediately for the whole world, not for us only.
Okay, well, thank you, Vladimir. So what I see and what you're saying is you've sort of given us a reason to believe in an absolute universal time. Okay, so you've given us a physical reason, which I think is interesting. And my point really basically of what I was really aiming at is I think this, what Einstein starts off with is relative. I think Einstein's relative time is a dead end. And because we have this confusion of, now we have to talk about what we think time is. That gets into physics, and we're not really in physical realism anymore. Okay, which I don't think is physics. what you're saying, Vladimir, I think, is that time comes into being when there's a physical entity in which time can operate. That's kind of my interpretation of what you're saying. And you're saying that the universe as a physical thing has a time when it emerges to the state where physical processes exist in a classical sense. That's my simplistic way of understanding what you're saying.
Well, I thought that
I'm very happy for your simplistic explanation. Thank you so much.
Einstein just screwed physics up. Now I'm becoming to realize that he screwed everything up.
Absolutely right, Rick. You're absolutely right. He linked classical physics for 120 years. 905 paper and skilled all the classical physics. Do you know that all the classical physicists, the real one, they didn't accept this,
Oh, I know.
relativity, special, great,
I know
general.
the main physicists that didn't accept Einstein's theory during the discussions passed away. So there was no
passed
voice.
away.
There was no voice
Sorry, who's that?
opposing.
Who's that you're referring to?
I can't remember the
Lorentz.
physicist's name. No, it was not
Tesla
Lorentz.
disagreed.
Well, I know Michelson never accepted actually Einstein's special relativity theory.
Mach neither.
Yeah, quite interesting.
There was a bunch of them
Nobody.
that didn't accept it, but there was one main physicist that everybody was.
Well, Lorentz, but he eventually caved
Yeah.
in, I think.
Yeah,
No,
sort
he
of,
didn't.
reluctantly.
Die. He didn't die. He didn't die, Lorentz, at
Oh, you're
around that
talking
time of that
about Planck
conference.
or
Not Planck. It was some other
You're talking about
physicist.
dying around 1905, are you?
Niels Bohr, maybe.
No, no, much later. No.
no.
Rutherford never accepted it either, but he died much later, in the late 30s or something.
But there was. I can't remember
But
the
what is
physicist's
important,
name.
they didn't accept. That's it, simple like this.
Because there was no opposition, or the opposition had passed away. It
Then we
became
talked about
an
Herbert
accepted
Ives
theory.
some weeks ago. He never accepted it either. We talked about that, Harry, as well.
Well, I know some of the most brilliant philosophers that I've read books from, Bertrand Russell and Morris Raphael Cohen and others. They were fooled by relativity. I mean, they wrote about it as if they knew what they were talking about. But I mean, they were so brilliant in so many other ways.
Yeah, I think that's an interesting point, and kind of philosophy, what's his name? Bergson, Henry Bergson, who was the acknowledged expert of philosophy of time, supposedly. That's how they describe him. When he had this discussion with at a conference about Einstein's, and he rejected Einstein's time, they basically crucified him. And so the point being, the time switched from being the domain of philosophy to physics, and now physicists